Hello everyone and welcome to the part 2 of the dynamic list in C implementation. So I've already gotten comments about that people want to see how to remove items from the list as well, because in the previous video we made it possible to append items to the list, but we never made it possible to also remove items from the list because I don't know, I wanted to save it for another video because the video would get too long otherwise. But today we're going to make it possible to remove items from the list. Okay, so the first thing we need to do is a method to shift the items in the list left. What I mean by that is, let's say we have a list of items like this, A, B, C, D, E, F, G, H. And let's say we want to remove the C here. Okay, the way we're going to do that is that we're going to create a loop that starts from the index where C is at. So that index is 0, 1, 2. The C is at index 2. So we're going to loop from 2, and we're going to say that the current index is going to be the next index plus 1. So C is going to become D. And D here is going to become E, and E here is going to become F, and F here is going to become G, G is going to become H, and so on. And as you can see, the C was now removed. So let's create this method here. We're going to do void dynamic list shift left. And we need the first argument to be the list that we want to shift. So we're going to do dynamic list T, dynamic list. And we need an index as well. So int index, and the index in this case is the item we want to remove. Okay, so we're going to do for int I is equal to index. If I is less than dynamic list length minus 1, I plus plus. Okay, and now we're going to do the shifting here. So we're going to do dynamic list items I is equal to dynamic list items I plus 1. Okay. So now our shift method here is done, and we're going to use this method inside of our remove method basically. So we're going to have another method called void dynamic list, let's just call it remove, and we need a pointer to the list, dynamic list, and we're going to want an item that we are to remove. So let's do void item. Now, the first thing we need to do is to find the index of this item in our list. So we're going to do int index is equal to 0. For int I is equal to 0. If I is less than dynamic list size, I plus plus. Okay. Then we're going to do if item is equal to dynamic list items I, we found the item, then we can do a index is equal to I break. Okay, so now we have found the index of the item we want to remove. Okay, so the next thing we want to do is actually dynamic list shift left. So now we're going to call our shift method, and we're going to pass in the dynamic list and the index. Okay. Now we're not quite done yet. We also have to reallocate the size of our list. So we have to do dynamic list items is equal to realloc dynamic list items dynamic list size times dynamic list item size. Okay. And actually, after we have shifted, we've called the shift here, we also want to decrease the size. So we're going to do dynamic list length minus equals 1. This should be length as well. Okay. And I think that's it. I guess we can just try it out and see what happens. Usually I miss something. So let's reduce our code here a little bit to, let's just only have the animals now to make things simple. And actually let's put these outside here instead. Oh God. Like that. Remove some parentheses. And then we can do actually let's keep them in here. And let's do it like this. Let's just have one of them outside instead, because I want to show you something. So animal t cow is equal to that. Okay. So if we compile this now, we have a error. So I'm using size instead of length. Sorry about that. And it works, so we're still having our animals printed here. Okay, now let's say we want to remove the cow. Let's print 2 times, so let's print 1 time before we remove the cow and 1 time after we remove the cow. So let's just do a print here. Print before removal. Printf. Oh, come on. After removal. Okay, if we compile it, we're getting a syntax error. If we compile it again and we run it, now obviously we haven't removed the item yet, so the prints are the same here. But now let's try to remove the cow. So we're going to do dynamic list remove, and we're going to say we want to remove something from our list, and we want to remove the cow. If we run it, we can see that after removal, the cow vanished from our list. So that works. Of course, you can remove the other ones as well. But the reason I put the cow outside here is because I wanted to be able to grab this pointer here. We could fix this in another way. We can still have this in here. And we can change our append function to actually return the pointer of whatever item we put into it. So if we go to the append function and we change this to void pointer instead, whoops, and then we can return the item that we added. Okay, then we can do, let's say we want to remove the bird, we can do void bird is equal to, and then we can remove the bird. And now we can't see the bird in the list after removal. So that works. However, there is one problem with this, and it's that we're going to leak memory when we remove something. So what you want to do is you want to have the remove function here to also accept a free method, a method to be used to free the pointer, basically. So we're going to do a void, how do I do this? Void void free method. I think this is how you do it. Might be wrong. Free method, okay. And then we want to do if free method. So if we have a free method, then we can call free method item. Okay, if we compile this, we're getting an error. Too few arguments. Okay, so now we have to pass in an argument to the free method, or to the remove method, sorry. So if we just do void pointer here now, it shouldn't use our function. Free method is not a function or a pointer, right? Because we have to do that as well, I think. Yeah, so now that works. However, this isn't really great. We also need to have a void, let's just call it x. Okay. Okay. So now we still haven't passed any method to the to be used as a free method. But what we can do is create a method that we will pass into there. So we're going to create a method called, because the thing we're removing here is a animal, right? So we need to create a method to free an animal, basically to deallocate an animal. And to do that, we would just do a void animal free, which takes in a void x pointer. It doesn't have to say x, but you know, we used this is the argument we're gonna pass, that the function here in our signature expects, the function pointer expects a void pointer. The function pointer expects a void pointer. pointer. Anyway, so here's our animal free. So first we need to convert it to an animal. So we need to do animal t animal is equal to animal t x. Okay. And the reason we need to do that is because the animal has a name on it, right? And we need to free that string basically. So what we will do is free animal name and also free animal. So we're freeing the name, that is the string that is stored on the animal, and we're also freeing the actual animal struct instance here. Okay, so now we can actually pass in animal free here, animal free, and the memory should be deallocated for that bird that we are removing. Cool. So that's pretty good. Maybe we should validate that we're actually freeing that data, you know? So the way we can do this is by using valgrind. So before we do this, let's just bring back the void pointer here and compile it again and run it, because we wanna compare the memory that the bytes that we're leaking before we add a free method. Okay, so now we can do a I think what we want to do is add some flags here. We want to do G and wall, I think, and then we can do valgrind a.out, and we can see here that we're leaking memory. Okay, we definitely lost 32 bytes. Now there are multiple areas here where we're leaking memory actually, so maybe we should fix the other ones first. So we have this dynamic list here, and we also need a way to free that list. Okay, so we have a way to create the list, but we also need a way to free that list. So to do that, we can just do void dynamic list free. So we're going to have a method to free a dynamic list, basically. So dynamic list t dynamic list, and this will also accept a free method actually. So we're going to have void free method void x. Okay. So what we're going to do here is that we're going to free every item in the list. So we're going to do for int I is equal to 0 if I is less than dynamic list length I++, and we're going to do free method dynamic list items I. So we're calling the passed in free method on every item. And then we're going to do free dynamic list items and free dynamic list. Okay, so now we have a way to free an entire dynamic list. So let's use that. Let's use that at the end of our main function, dynamic list free list. So we're going to free the entire list, and we need to pass in a free method. So let's use animal free, because we know it's a list of animals. Let's compile it and let's run Valgrind again. And now we're only leaking 8 bytes. We're only leaking 8 bytes. So we have successfully freed our list. But the reason we're leaking 8 bytes is because, you know, before we free our list, we're actually removing an item from the list without freeing it, which means that we have leaked bytes that we no longer have control over, basically. The bytes that we shifted here in our shift function are completely lost. We don't know where they are now. So now we also need to pass in our animal free here when we remove an item. Let's compile it, let's run Valgrind, and as you can see, we're not leaking any bytes anymore. In use at exit 0 bytes, all heap blocks were freed, no leaks are possible. Cool, so we also solved the memory leaks. So yeah, now you can, and of course you can remove how many items you want from this list. We can remove, let's remove the dog as well. So we're removing the dog, the bird, and the cat maybe. Dog, bird, cat. We're removing the dog and the bird and the cat. Okay. And as you can see, now we're only seeing the cow and the fish after removal. Cool. So that's how you implement the function to remove an item. Now, we did stray away a little bit. We also fixed the memory leaks, but it's also important. Now, of course, maybe one would like to remove an item from the list by just using an index. That's possible as well, of course. The way we could do that is just write another function like this that just takes in an integer instead. So we can just we can create a copy of this one. Let's put it here. We can call this dynamic list remove by index, and we can remove the void item and replace that with int index, and then we can remove this loop here because now we already have the index. And now we can actually use this function inside of our dynamic list remove instead to remove the item, because so the way we would do it is go into this dynamic list remove, and we would remove everything below our for loop here, because we still need to find the index, okay? But now we can do dynamic list remove by index, dynamic list item free method. So we're still passing all the arguments down to this function again, okay? Let's just see if it compiles. It does not compile. Why does it not compile? It's because we don't know. Now we don't have the item anymore. So, but we can get the item by doing dynamic list items index. Okay. And we should probably do the shift after we free it, I think. Or should we? Yeah, we should probably do that. Okay. We should probably do it like that. Okay. So now we have our dynamic list removed by index, where we just pass in an index. And it's shifting it, and then we're freeing the item at that index. The problem is though that we're shifting it, so this thing here will be wrong. I actually think we should have it like that. Okay. Okay. And then we have the dynamic list remove. All we're doing here is looking up the index, because since you passed in the pointer, we don't have the index, so we need to do a lookup here. So let's just see if everything works the way it did before, I guess. Compile it, and we're still getting an error here. Makes integer okay. Item, of course. We should pass in the index here in this case. Remove by index, passing index, okay. And now it's compiling. If we run it, yeah, we're still getting the same behavior. Cool, so that seems to be working. So let's try to use the remove by index function as well. So instead of storing the items in pointers like this, we should now just be able to pass in an index. So let's just start off by not removing anything. And if we compile this, run it, we're still getting everything. So this list is the same after removal. So now let's do remove by index, and I want to remove the let's remove the cat. So 0, 1, 1, and the cat was removed. Cool. So now you can remove items by index as well. Maybe we want to remove the maybe we want to remove the bird instead. So let's do 3. So now the bird should be gone. The bird is gone. Cool. And I mean, you could even simplify this even more. You could this loop here could be put in a separate function. You could do like this. You could do unsigned int dynamic list get item index dynamic list t dynamic list void item. So all this function is going to do is to look up the index that we're interested in. Now we can remove the break and that, and we could just return I. We could even simplify it even more. We could do it like that. And oh, actually, let's make it an int. And if we don't find the item, let's just return -1. Okay, so now we can just do, in our dynamic list remove function, we remove the for loop and put that in a function instead. So now we can, in the index parameter here, we could just do dynamic list get item index dynamic list item. And we could wrap that function call into multiple lines just so that it's prettier and easier to read, I guess. There we go. So that simplified things a bit. Now, of course, it's possible that this function is going to return a -1 if it doesn't find the item. So in our remove by index here, maybe we should check that if index is equal to -1, then we're just going to return. We're not going to do anything. Okay. Let's try it out. So we're still removing the 0, 1, 2, 3. We're still removing the bird. Let's see if it still works. Yep, the bird is still gone. Cool. And can we remove the fish by pointer? Dynamic list, remove list fish animal free. And yeah, we remove the fish as well by pointer. Are we leaking any memory? No, all blocks are free, no leaks are possible. Cool. So there you have it, guys. We are now able to remove items from the list, and we can remove them by index, we can remove them by pointer, and we're also making sure we're not leaking any memory. Now, you know, we have this person structure as well. If you're going to make a list where you push person items into it, you're going to need another free method to free persons, basically. Now, in this case, this person structure doesn't have anything we need to free, so you could just call free on it directly. But anyway, that's how you do it. I hope this helped you. It was pretty fun to make this video, actually. So yeah, if you have any questions, just put them in a comment, and I'll see you in the next video.